Welcome to Sc130 Module 5. Last week you did chemical reactions in the lab. I hope you find that useful in understanding how atoms behave, because chemical reactions are everywhere. Why do things rust? Chemical reaction. Why do things decay and erode? Chemical reaction. Why is it that concrete breaks down over time? Chemical reactions going on. Why do things change colour and is the effect of weathering? There's a chemical reaction going on. What about batteries and how they work? Well, there's a chemical reaction going on. So lots of applications of them. And what we're going to learn today is the types of chemical reactions and how we can predict the exact arrangements and movements of atoms in a chemical equation. So there's some of the outcomes that we're going to have today. First of all, you explored chemical reactions last week, but a fundamental question is, what is this? Is this a chemical reaction or not? So some things, for example, might change colour and they go back between different colours. Does that mean a chemical reaction came on? Or is that something to do with the light or dispersing things differently? So here's, however, it's a suspicion that a chemical reaction. Here they are. And you notice things in your reactions that, yes, things did change colour. You notice some gas was produced when we had acid with our metals. There was heat given off. And we perhaps saw a new substance being formed. Well, they're all good indicators. For me, the biggest one is the irreversibility of it. In other words, if things cannot be changed, they can't flip back and forth, then we've got a chemical reaction going on. If things can go back and forth, perhaps it's actually a physical change going on, not a chemical change. So the first thing is, there's our list of what chemical reactions are. So let's say, okay, we have a chemical reaction. What sort of types are there? Some things you add two substances together to produce a new thing. That's a synthesis or a combination one. Some things you have something which breaks down, for example, in a decaying reaction. Or sometimes we have things adding together and it being exchanged going on, so a double displacement. The names are not so important to us. It's really about what is going on in terms of the atoms. So chemical reactions are written in equation forms. Let's have a look at this one here. Sodium chloride with silver nitrate makes silver chloride and sodium nitrate. There's been an exchange, hasn't there? The chlorine has gone to the silver and the nitrate ion has gone to the sodium. There's been a change going on. So this is what we call a chemical equation. It's a sentence that describes what is going on. Now, part of being a chemist is actually to understand and identify what's occurred, but also to document and ultimately come up with a chemical equation, and then how can we manipulate that as a chemist. So here's a useful video, which will go through some of those chemical reactions you've already seen and others. But the basis of today is to look at that chemical equation. Here's something visual that describes it. Methane plus oxygen gives carbon dioxide and water. That was the combustion reaction, that one of those that you did last week. So that's where God can create and destroy things, and he has a miraculous power. But the rest of us, we usually don't, unless God's working through us, have those abilities. So we have to apply the law of conservation of mass and energy. In other words, what we start with, we end up with. I like it in the sense saying a way of looking at it is the number of Lego pieces that you start with will end up with the number of Lego pieces you end up with, but they're just now arranged in different forms. And why things change has got to do with, as we discussed previously, about the structure of the atom and their outer shell and how they bond together. But let's have a look at some chemical equations. Well, first one we had a look at here. Well, how many carbon atoms, Lego blocks, did we have at the beginning? We had one. And we've got 4 hydrogen, we've got 2 lots of O2, so that's 4 oxygen altogether. So we've got 1 carbon, 4 hydrogen, and 4 oxygen. Well, when they recombine, they have to recombine all those together. At the other side, carbon dioxide, well, there's 1 carbon, and we've got 2 oxygen atoms. There's 2 hydrogen, water molecules. 2 times 2, that's 4 hydrogen altogether, which is the white ones, and 2 O's, 2 oxygens, the red ones. So altogether we started with 1 carbon, ended up with 1 carbon. We started with 4 hydrogen, we ended up with 1, 2, 3, 4 hydrogen. And we had 1, 2, 3, 4 oxygen, and we've ended up with 1, 2, 3, 4 oxygen there. That's what we call a balanced chemical equation. So what we're going to do this week is go through the process of balancing chemical equations. There's worksheets that I've asked you to put in the homework and the revision webpage. And this is an excellent video which documents those. So through the process, you'll learn to see what things will change in terms of their chemistry, and then how can we write a chemical sentence or an equation. And it's important that the atoms add up, so it's a balanced chemical equation. So here a number of tools. This is quite good because it allows you to play around with the numbers and until you get there. Hopefully you get more confident on how to write chemical equations and understanding the process.